Hello, my name is Patrick Webb, and we're continuing our discussion of the chemistry of plaster and heritage building with a consideration in part 3 of the aggregates and fibers that are often added to the binders. We're going to look at it in a couple different ways. One is the types of qualities that aggregates can have, and also examples of which type of aggregates manifest these qualities. So the first quality that we're going to discuss is that of sharpness. Sharpness is important for some of the binders, particularly lime and the lime derivatives, natural hydraulic lime, natural cement, less so. Sharpness of an aggregate gives something for the lime and natural hydraulic lime to bind around. And examples of sharp sands might be silica sand, glass, that's definitely sharp, and it allows you to build up these coatings pretty thick, quarter inch, half inch at a time. If you were to use a smooth sand by contrast, like a river sand, you won't be able to build it up as thick. Now, sometimes some of the more putty type limes, like finished lime coats, will use on purpose a sand that's not as sharp because it's easier to lay down and get a nice smooth finish. But you can't build it up as thick, sometimes an eighth of an inch or even thinner, like a 16th of an inch. Absorption. The sands that we just mentioned, like silica sand, glass, crushed marble would be another example. They don't tend to be very absorbative. But for particularly a lot of the non-hydraulic lime work, it's very useful to have this aggregate that has a lot of absorption. Cacio pesto would be a good example of that. The benefit of that is those limes need to retain moisture. Those stuccos need to retain moisture for a period of time so that they can fully carbonize. And by having an aggregate that retains the moisture, as the binder starts to dry out, it imparts moisture from the inside and allows the carbonation to take place fully. Also, probably a porous limestone, pumice, these are also good examples of absorbative aggregates that were used quite a lot in heritage building. Granulometry is also important for lime-based aggregates that are used in lime-based binders. You need a good spread. So you need to have very large aggregates, some small at the bottom, and in the middle, a good range of medium-sized aggregates. So a lot of times your supplier of plaster or stucco sands will have this kind of figured out, but it's always good to run a test yourself. Softness. This can be very important, particularly in decorative plaster work. If you have some of the softer types of aggregates, such as chalk is a good example. Some of the raw gypsums are also very soft and useful as an aggregate. Particularly in gypsum-based plasters, you can get some beautiful decorative effects. Think of stucchiere, looking like limestone where they cut the face of the surface. Having an aggregate that even after just a little time of setting, the aggregate is actually softer than the binder, allows you to cut a clean face and have a product that looks like a honed stone finish. Weight and insulative value. Although we use this a lot in modern construction, it's been known for a long time, the use of certain types of minerals called perlites or vermiculites that were the result of volcanic activity. They're super lightweight aggregates, and they're good as insulators for fire, just sound insulators as well, and they lower the overall weight of the coating. So yeah, very, very useful aggregates. They work well in everything, in limes and gypsums, and they have a specialty use. Not always the easiest to get to apply, get a real nice finish, but a lot of times you can build up with those type of coatings, and A lot of times in ornamental plaster, if we're doing a column shaft, we'll coat the inside with like a gypsum that has vermiculites in it, so that when you knock on it, it doesn't have that hollow ring, but it absorbs the sound. And then for tensile strength, well, that's when we start adding fibers. And by tensile strength, we mean it makes the product, the resulting plaster, less liable to crack. A lot of things have been added over the years. Hemp, various hairs, even seaweed. Japanese have a big tradition of putting seaweed in. Keratin is the protein that gives it that tensile strength. So it's interesting to know about all of these, and it's just a basic overview. Perhaps as we're discussing the individual binders, we'll talk about more in depth about which aggregates and fibers might be useful for each one.